In this second session about ACLs, we're going to talk about IPv6 access list, object groups, reflexible ACLs, ACL logging, access list design principles, and final thoughts on ACLs. Okay, first of all, we are going to talk about IPv6 access control list. We can only create named extended IPv6 access control list with this command. We can also create fully qualified domain name IPv6 ACLs with this command. Notice that we will use this parameter in order to use host names rather than IP addresses. This device must be configured to consult a DNS server in order for this to work. And in order to apply an IPv6 ACL to an interface, we're going to use the command IPv6 traffic filter, the name of the ACL, and the direction. Now let's talk about this other feature that is known as object groups. This feature has been available in Cisco firewalls for several years now. For instance, we have had it with Cisco ASA firewalls. Nowadays, we can use it with iOS XE. We can create, for instance, network object groups that are going to hold IP prefixes, or we can create services object groups that are going to hold port numbers. With object groups, our ACLs are going to become shorter, they are going to become easier to read, and they are going to become easier to manage. In this example, we are showing how to create an ACL with object groups and how to create the same ACL without object groups. When using object groups, we are going to create the object group first with the command object group, the type of object group, and the name. In this case, we are creating a network object group that is known as my LAN networks that includes 2 prefixes. Then we are creating an extended access control list that only has 1 entry. Within this entry, as source address, we are actually making a reference to the object group that we created previously. Notice that this rule actually has an effect on these 2 prefixes. Notice that for the ACL that is using object groups, we are achieving the same result using only 1 entry, whereas with the ACL that is not using object groups, we require 2 entries. That is why we say that with object groups, our ACLs become shorter. Notice that given I am using names for my object groups, when I read my entries within my ACL, these entries make more sense than reading entries within an ACL that is not using object groups. This is why when using object groups, my ACLs become easier to read. Notice that if I wanted to apply this rule to more prefixes, I will need to modify the object group only. So I can add more prefixes to the object group, I can modify prefixes within it, I can delete prefixes from it, and I will never need to modify the access control list. Compare that with the old way, where if I wanted to modify a prefix, add a prefix, or delete a prefix, I will actually need to modify the actual access control list. This is why with object groups, access control lists become easier to manage. Finally, we are showing how to create a service object group. Now let's talk about reflexible ACLs. With reflexible ACLs, we can provide basic stateful inspection in a similar way to what firewalls provide. However, reflexible ACLs are processed in software. They do not provide complete stateful inspection. It is not recommended to use this feature because we should rather use an actual firewall. Okay, now we are going to see how exactly are we going to use a reflexible ACL. So within our Catalyst 9000, we are going to use this feature in an interface that is pointing to an external network. Let's say the internet. In this case, we are going to configure in this interface 2 ACLs, the outbound ACL and the inbound ACL. In this example, the outbound ACL is going to be called outbound, and the inbound ACL is going to be called inbound. Notice that within the outbound ACL, we are going to make use of the reflexible ACL using the parameter reflect and the name of our reflexible ACL. So this will be the actual stateful inspection database. And within the inbound ACL, we are going to reference this reflexible ACL with the command evaluate and the name of this ACL. Now let's talk about ACL logging. When using this feature, if a packet matches a particular entry within our ACL, we are going to use the syslog subsystem in order to create a log entry for this match. If we use log as a parameter for our entry, we are just going to create a record saying what is the IP address of the packet that matched a certain entry. But if we use log input, we are going to generate more information. For instance, the input interface and the MAC address for this packet. Now let's talk about access list best practices. Probably the most important one is that we should place more specific ACLs as close as possible to the source. In that case, we should use extended ACLs. We should use object groups because with object groups, our ACLs become shorter, they become easier to read and easier to manage. There is the possibility to use reflexive ACLs in order to provide a stateful inspection. However, we should save that as only a last resource. We should rather use real firewalls. Some final thoughts on ACLs. Even though we have been working with these traditional ACLs with Cisco for several decades now, that does not mean that these traditional ACLs are the best solution for our needs. Traditional ACLs are not scalable. They bring several management issues. Let's talk about them. For instance, traditional ACLs are static in nature. When we configure an ACL for a port, that ACL applies for that port always. What if we wanted more flexibility? What if we wanted to have dynamic ACLs per port? That is really difficult to do with traditional ACLs. Traditional ACLs are distributed in nature. That means that if we want to add a new rule, modify a new rule, or delete a rule within our enterprise network, we actually have to go through every single device within our network that has ACLs. And within each of these devices, we have to go through every single type of ACLs that this device may have. And we are going to do that manually. Furthermore, there are several types of ACLs. We have port ACLs, VLAN ACLs, and traditional layer 3 ACLs. This makes more difficult to troubleshoot an ACL issue because we may overlook, for instance, that a VLAN access control list exists in a certain switch. The good news is that with SD access, we now have a new generation of ACLs. We now can work with scalable group tag ACLs, which are centralized in management, dynamic in nature. We no longer have to deal with several types of ACLs. Probably the only issue with this type of new ACLs is that they are going to enforce rules when traffic exits our network.